Hello ladies and gentlemen, so today we're going to look at section 6.5, which is on graphing linear inequalities. What you're going to want to have on you is that bright pink note sheet I gave you, your notebook, and then a pen or a pencil today. So very first thing that we're going to do is check whether ordered pairs are solutions of the inequality. So basically all you're going to need to do is take your variables, or take the numbers they give you. In this case, they gave me a 3 and a 2, and you're going to call that your x and your y. So what you're going to want to do is plug that into this equation. So wherever I see an x, I'm going to put a 3, and wherever I see a 2, I put a y. Or wherever I see a y, I put a 2, excuse me. So we're going to have 4 times 3 plus 2 times 2 is greater than 6. So now let's figure it out. 4 times 3, that is 12. 2 times 2 is 4. So we have 12 plus 4, that is 16. Whoops. There we go. And I have 16 is greater than 6. So now I need to ask myself, is 16 greater than 6? Yes. So this is a yes, it does fit. Now let's check this one. They want us to put in -1 for x and 4 for y. So 4 times -1, we know that's -4. 2 times 4, that's 8. -4 plus 8, we know that's 4. Now, remember, this is a greater than symbol, so 4 is greater than 6. You're right, that's not true. So this is a x on that. No, not a solution. Let's check one more set here. So I have 2 times 6, because my x is 6, minus my y, which is 2. So I have 2 times 6, that's 12, minus 2. That's 10. Is 10 less than or equal to 8? Nope. So that one is also a no. Let's check this one. 2 times 3 minus y. Oh, excuse me. We know what y is, don't we? That should be a -1. There we go. 2 times 3, then we know that's 6. Negative and negative, let's make that a positive. So 6 plus 1, that's 7. Is 7 less than or equal to 8? Yes, indeed. So that's the very first kind of things that we're going to look at. Now, this is when you're going to want to get that pink sheet out, and we're going to start filling in the directions. And as we fill in the directions, I'm actually going to walk through the example that we have on here. So the very first step to graphing a linear inequality is you're going to solve for y. That way we can actually graph it. So we have 2x minus 3y is less than 12. So we need to solve for y. So to do that, I'm going to subtract 2x. -3y is less than -2x plus 12. Looks like I need to divide by -3. But now, do you remember something that we had to do? We divided by a negative when we did inequalities. We had to flip the sign, right? So we had to flip the inequality symbol. See how it was less than? Now it's going to become a greater than. So now I have 2/3 x minus 4 for my equation. So I solved for my y. Now we need to graph that line using slope and y-intercepts. So my line's going to start at my y-intercept of -4. So 1, 2, 3, 4. Here's 4 right there. Use my slope. So up 2 over 3. 1, 2, 1, 2, 3. Run right there. 1, 2, 1, 2. Oh, that's 1, 2, 1, 2, 3, right there. 2, right there. Right about there. Right there. And right there. So now, before you start connecting dots, we need to ask yourself, is it a solid line or a dashed line? So remember when we made inequalities with one variable, we had a solid, a closed dot or open dot? Well, solid line or dashed line kind of signifies that. So you're going to use a solid line when you have greater than or equal to or less than or equal to. Like that. So you're either going to use a solid line when it's greater than or equal to or less than or equal to. Dashed lines, you can only assume, would be when you have a less than or a greater than. So let's look at this problem. Do we have a less than or an equal to or a non-equal to one? A non-equal to, right? We just have greater than here. So we're going to make a dashed line. So let's make a dashed line. There we go. Or a dotted line if you want to call it that. And the last and very most important part, shading the solution set. So now, to do that, what you're going to do is that's this little check area right here. You're going to plug in the point 0, 0 into the original equation. This is going to allow you to figure out what side do you get to shade on. So on this one, let's plug in 0, 0. So I have 2 times 0 minus 3 times 0 is less than 12. So I just took it and put it into my original equation. That's 0 minus 0, so that's just got to be 0 there. So then I ask myself, is 0 less than 12? Yes. So what you're going to do, if this is a true statement, if you get a yes here, you are going to shade on the side of 0, 0. 0, 0 worked. So we are going to find 0, 0, and on that side of the line, you're going to scribble. That's going to tell you, hey, on this side of the line, that is where my solutions lie. And finally, under the stars, don't forget to change the sign when you divide by a negative. Otherwise, you will not get the correct shaded area. So please make sure you change the sign if you divide by a negative. Be kind of wary about that. We're going to try one more here. So we have 9x plus 3y is greater than 9. So let's follow all of our steps. First thing first, solve for y. So let's get y alone here. Alright, divide by 3 it looks like. There we go. So we solve for y. So step 2 says graph line using slope and y-intercept. So I'm going to start at my y-intercept of 3. Go down 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. Up 3 over 1. And up 3 over 1. So now, before you start connecting dots, what's the next question we have to ask ourselves? Is it a solid line or a dashed line, right? So I have a greater than symbol. So I'll look on my handy dandy little note sheet, and I see that that means I need a dashed line. So we're going to make a dashed line here. There we go. Make my arrowheads. And then we get to check. So let's put 0, 0 in for x and y. See if it works. So we get 0 is greater than 9. Is 0 greater than 9? No. Shouldn't be, right? So we can't shade on the side of 0 because this is a no. This doesn't work. So we can't shade on 0, 0. We gotta go opposite side. And shade on that side. Alright? That is the end of the video. Have a good night.